This is Math Study C, section 11.3, single variable graphs. So the last section we talked about the 5-number summary, the minimum, the first quartile, the median, the third quartile, and the maximum. Those 5 numbers can be used in a box and whisker plot, or sometimes just called a box plot, as follows. The minimum, you put a dot, the first quartile a line, the median a line, the third quartile a line, the maximum a dot. You draw a box around the middle 3, and then you draw whiskers that extend to the min and the max. So I have a list of numbers here, and I want to use that to draw a box plot. So I'm going to find my minimum and my maximum, and then I have to cross off and find my median. And then when we're looking for our quartiles, we're going to cross off again. We cross off, I'll do it on the bottom this time. So that's going to be right here. And right here. So the minimum is 2, the first quartile is 4, the median is 5.5, the third quartile is 6.5, and the max is 9. A box plot always starts with a number line. Hopefully whatever number line you're drawing is a little straighter than mine was. So I have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Ideally you should write the numbers below. Since it's really difficult for me to write numbers with my mouse on the computer, I'm not going to write them. But this is 0, 1, 2, so I'm going to put a point above 2. 3, 4, put a point above 4. 5 and a half. 6 and a half. 7, 8, 9. So with my middle 3 points, I will draw the box, and then the vertical line representing the median, and then to reach the max and the min, draw the whiskers, and that is a box plot. The next bit of notes talks about a stem and leaf plot, sometimes simply called a stem plot. Now, stem and leaf plots are valuable when you have multi-digit numbers. They wouldn't be very useful with a single-digit number or single-digit data like we had above. That wouldn't work here. But double-digit numbers, like we have here, work with a stem plot. For a stem plot, you put the tens digit on one side of the line. That represents the stem. Then you draw a vertical line, and then we put the leaves, or the second digit of each of the numbers, on the other side of the line, and those would go in order. The other thing is you should always have a key denoting what the numbers mean, because this could mean 0.9 or it could mean 9. This could mean 1.3 or 13 or even 130 depending on what your key represented. So for this data over here, I need to find the minimum, and I believe 18 is the minimum, and I need to find the maximum. I believe 54 is the maximum. So for my stems, I'm going to go 1, 2, 3, 4, 5. Identifying the max and the min told me where to start and where to end. And then I'm going to build off my leaves. So I have 18 and I have no other number in the tens, so I know that's going to be an 8. I'm going to look for my 20s. I have a 20, a 20, a 20, a 26, a 22, a 27, I have 3 20s, so I'm going to go 0, 0, 0. I have a 22, a 26, and a 27. So if you go through later and notice, oop, I missed a 21, you'd have to squeeze that one in here because these numbers should be in order. Out of my 30s, I have a 31, a 32, 3, 6, 9, 9, 4. All the rest are 30s except for that 54. So let's make sure I get them in order. 31, 32, 33, 34, 36, and then 2 39s. And in a perfect world as well, these would be lined up. I'm not very good at that on the computer screen, but so we can tell, you know, which one kind of has more numbers in it. 40s I have none, and all I have left is that 54 here. So stem plots are kind of like bar graphs turned on their side. And that I have a single bar, or a 1 tall bar here. In the 20s, I have a 1, 2, 3, 4, 5, 6. I have a 6 tall bar in the 20s. In the 30s, I have a 7 tall bar. In the 40s, I have a gap. And gaps are significant just like clusters are. And then in the 50s, I have a 1 tall bar. So that is it for the stem plots. Oop, I didn't have a key, did I? 1, 8 means 18. That's it for the notes. Good luck with the exercises.